What's up? Accelerated Algebra 2 Stirrup here, 11F. We're skipping E because that was kind of a review of A, B, C, and D. So we're going to start talking about the reciprocal function. A few things to note about this is where our variable is, our unknown, our x value. It's downstairs. And so you know that um, denominators can't be equal to 0. So we're going to focus on that. It's going to start dealing with a few things. So, do we have restrictions on domains? Yeah, there becomes values that we can't plug in because of where the variable x falls. And then what will affect the restriction on the graph? We'll see about that and talk about the x and the y intercepts because this is a kind of a strange looking graph. Um, so um, First thing we're going to talk about is, do we have a vertical asymptote? And if you remember, an asymptote is something that we can't cross. So a vertical asymptote would go up and down. And this does, when will the denominator equal 0? And in this case, x equals 0. So it happens to be a vertical asymptote. So I'm going to draw a vertical asymptote straight down this. Okay, you can tell, obviously, I can't draw straight at home either. So we have that. But then a couple other things we want to think about. As x gets to be a really big number, this fraction gets small. So as x, like if I plugged in 1 over 5, I get 1/5. This is 0.2. But I did 1 over 10, that's 0.1. If I did, 1 over 20, that's smaller. 1 over 100 is really small. So as this goes to infinity, this fraction gets small and it gets really close to 0. Okay, but it'll never get there. And then if I plugged in negative values, the negative values would also be. So this has something called a horizontal asymptote because it's never going to be equal to 0 in this case. Okay, so we have a horizontal asymptote, and the horizontal asymptote is at y equals 0. And so we have a horizontal asymptote that looks like this. Okay, those are two lines that we can't cross with our graph, which it's like, wait a minute, we just added more asymptotes? It's like, yeah, sorry about that. Wish we were in class to do this because I'd probably do a better job than I'm doing now. But let's think about a couple values. If I've plugged in, say, 1 over 1 is just 1, so I get 1 comma 1. But what would happen if I were to plug in 2? I would get 1/2. If I plugged in 3, I'd get 1/3. If I plugged in other values, I would get really tall values. So this graph does this, but it also flips over, in this case, the origin, the x and y axis. So this is what our graph looks like. They're actually hyperbolas, which are part of the conic sections, but we didn't really talk about that. So let's not worry about that. So does it cross the x-intercept? No, they don't exist. What about the y-intercept? Well, this particular graph won't cross the y-intercept either because it has both the vertical and the horizontal asymptote. And that's a lot different than what we're used to. Okay, so let's kind of keep that in mind. Our graphs are all going to look kind of similar to that. And let's figure out some of the rules of why they do it. So this graph had the following characteristics. Asymptotes, often vertical and horizontal in these cases. And again, remember I said this is called a hyperbola. And hyperbolas always happen in pairs. There's two parts to it. So that's why we have the two parts of our graph. The domain and range have values that do not work. And there's two symmetrical parts called the branches. So the branches, if we look back at this would have been a branch and this would have been a branch. Okay. And again, when I said hyperbolas happen in pairs, that's your pair that is with your hyperbola. Okay. So let's talk about this one. This one, we have 3. So we still have a vertical asymptote at x equals 0. Excuse me. So vertical asymptote right here. And we still have a horizontal asymptote at y equals 0. Okay, this is the same. But think about when we plug things in. If I plug in 3, if I plug in 3, I get 3 over 3, which is 1. So 3 comma 1 happens about right there. So this graph does this, and still it looks the same, and we're just identifying that one point. And then if I were to plug in, say, -3, 3 over -3 is -1, and so I get -3, -1, so that would be down here. So again, we have our branches to our graph. It comes in pairs. We do have points that are easy to identify, but you get to a point where you start being able to realize this is what the graph looks like. And the points don't become the most important part of it, but I think for these cases it's pretty easy. X-intercepts, no, it doesn't cross the x-axis. Y-intercepts, no, it doesn't cross the y-axis either, okay, because we have asymptotes there. And again, the asymptote can't be crossed. All right, ooh, now we're going to change things up. So I bet you the vertical asymptote is still going to be 0 because that looks the same. The horizontal asymptote is also going to be 0 because it still looks the same, but we have a negative out front. And really what that negative does is, let's think about this. If I were to say plug 2 in, and the reason I'm picking 2 is that would make that fraction be 1, I'd get -1. So I'd get 2 -1. So look at this. It kind of flip-flopped. Okay, and if that flip-flop there, it's going to flip-flop here as well. So it changed from the quadrants, basically. So x and y intercepts, no on both still. But we do have those two asymptotes that do exist on both. Okay, so summarize with the effects. So the a value pretty much determines, does it happen here and here, or does it happen here or here? Okay, so if a is greater than 0, so it's positive, it's this one. If a is less than 0, so it's negative, it looks like this graph. And obviously it's not x's in there, it'd be this and this and this and this for our graphs. Okay, so as a gets larger, it kind of just pulls it away from where the asymptotes cross. Okay, kind of stretches it out a little bit. Okay, so now let's consider this. This part's going to interfere, so we have to realize that x can't equal 4 because that gives us our undefined term. So this would actually have a vertical asymptote. In this case, at x equals 4 would be the vertical asymptote. Because of that, it's opposite. You set it equal to 0, and that would just be our vertical asymptote. So what about when x is 0? Well, if x is 0 in this case, I would wind up getting 3 over -4. So that exists. Okay. Okay, so think about this. When x goes to -infinity, as that goes to -infinity up here, that becomes really, really, really negative, right? So that -4 is just really kind of what appears. And let's take a look at what these graphs start looking like once we get there. So we have a vertical asymptote at x equals h. So if we set that equal to 0, we find our vertical asymptote. The graphs are hyperbolas, but if we have a k value, if we added a k value out to the outside, that's going to shift the horizontal asymptote up or down. Okay, if it's positive, up; if it's negative, down. Okay, still the same rules. And then the domain is based off what this is. Our range is based off of what the k value is. Okay, so that's kind of important information to know as we go forward. So between these two graphs, you see the difference, and that b value out there, all it's going to do is just kind of move that away from where the two vertical and horizontal asymptotes cross. It kind of stretches it out a little bit. Okay. Okay, so let's graph this. Vertical asymptote, x equals 4. Do you see why? Because if I plug 4 into the original equation, I would get 0 in the denominator. So I get 4 right here as my vertical asymptote. And then where is our horizontal asymptote? It's going to be at y equals 0. okay, because we're not moving anything. There was nothing that we were adding out there, so it's not moving up or down. So it looks like this. But remember, we got this negative out here, so that negative switches it here and here, and you can verify that usually just by plugging in, a point or two. You can say, well, what happens if I plug 5 in? I'd get 5 minus 4 was 1. Negative 2 over 5 is negative 2, so 5, negative 2 is like right there. So it worked out really well. Does it cross the x-axis? This one still doesn't. Does it cross the y-axis? It does. But how in the heck, I can see on my graph that, hey, we crossed, and I can't imagine I was so fortunate that I graphed it 100% correct, so it having that positive 1, but let's verify what happens when it crosses there. So basically, where does it cross the y-axis? Well, if you plug 0 in for x, that's going to tell you where it's going to cross this line someplace, okay? So I get negative 2 over 0 minus 4, which is negative 4, so that becomes 1/2. So yeah, I was off a little bit, so it should have crossed down there. But I was just trying to draw it in. But this one does indeed cross the y-axis. Didn't cross the x-axis yet, but we'll get there eventually. Okay, so vertical asymptote, what do you think? X equals 3 sound good? Do you understand why it's x equals 3? Because if I plug 3 into the original fraction, that would make the denominator 0. The horizontal asymptote, though, in this case, we're adding the 2, so it's going to shift it up 2. Okay, when we look at this, that happens to be positive, so it's going to basically look like this and look like this. And take a look. Does this one cross the x-axis? And it does. But how do we know exactly where it's going to cross there? Well, if I wanted to plug in for the x-axis, would mean my y value would have to be 0. So if I plug my y value 0 in, I'm going to get this. And I'm going to subtract 2. I'm going to multiply the other side by the, and then distribute. Subtract the 6. So x equals negative 5 over 2, which is about negative 2.5. Let's see. Was I off? You know, I have a sign error. Oh, that should be a negative, negative over negative. So positive 5 over 2 over 2.5. So it should have crossed there. So we were off a little bit on our graph. But still, it does cross there. Does it cross the y-axis? It sure does. Where do I plug the 0 in to get where it crosses the y-axis? For the x, right? So if I plug 0 in for that, I'm going to get y equals 1 over 0 minus 3 is negative 3 plus 2. So 2 subtract 1/3 is basically 1 2/3. So 1 2/3, somewhere in there. There we go. A little bit different to think about this stuff. It's not impossible, it's just a much different graph than we've ever dealt with. Okay, so last slide is, hey, rewrite the functions so that y equals a single rational expression. Okay, well, I'm going to make that over 1. I want the same denominator to be x, so I'm going to get y equals 1 minus 5x over x. There you go. Do the same thing here. I want this to be over 1, so I'm going to multiply both top and bottom by x minus 2 and x minus 2. So I'm going to get y equals 3 plus, make sure you distribute 4 over x minus 2. Combine your like terms on top, so 3 minus 8 is negative 5 plus 4x over x minus 2. Not quite sure why we really need to know this, other than maybe we should be able to identify a different form of this. Actually, we'll probably deal with something called complex fractions. And again, just like always, friends, 720-273-8859. Happy to go over any homework problems. A lot of you have been contacting me. We've been doing Zoom lessons to go over these. So make sure you're getting this down, because this is material you will need for your next math class. Have a great day, everyone. Take care of everyone. Take care of one another.